how to interface the DC motor with the Arduino Uno. Before getting into the interface part, we will see the DC motor's basic principle. The motor's basic principle is when a current conducting wire is placed perpendicular in a magnetic field, it will experience a force. And the direction of this force is given in the can be determined by the Fleming's left hand rule. So here we have an interval diagram of a DC motor, simple DC motor. Here it has a permanent magnet which provides a constant magnetic field, and secondly, main part is the current conducting coil over here. This current conducting coil is tend to rotate or based on a shaft. It is wounded over a shaft to rotate, and at the end of the coil it will have copper plates which will be rotating along with the current conducting coil, and they will be touched with the carbon brushes. These carbon brushes will make the contact with this copper plates, so that the supply is applied to this coil constantly, even though this copper current conducting wires were rotated. So if this current conducting wire is rotating, they need a constant supply so that they keep on rotate. So now first, for example, I apply a positive voltage over here and negative voltage here. So there is a current flow in this direction, and it experiences a force in this direction. This coil experiences a force in the direction of the yellow arrow. So it turns, and this side copper plates comes this side, and this side one will go there. And at that time, this side arm will be here, and it will again we will get the current flow in this direction, so that it will again tend to move in the direction mentioned in this yellow arrow. So it will continuously repeat every time, so that the supply is constantly so the until the supply is given, it constantly rotates. Next thing is, if I reverse the polarity of the supply, what will happen is the current flow direction will change, and the force acting on this will be changed. So it will tend to rotate in the opposite direction, and due to this copper plates and carbon brushes, the supply will be keep on applied to these coils, and the shaft or rotor will continuously rotate. So the complete diagram, internal diagram of a DC motor, where these are the brushes which are permanent. Okay, they are not going to rotate, but this shaft and this copper plate, and over this copper plate, starting from this, we have the copper coil which will be rotating, and we have the permanent magnets for constant magnetic field, and this, so that this is called as stator and this part is called as rotor. So the rotor will get energized, and it will constantly move based on the supply applied. Okay, the polarity of the power supply applied to the DC motor. So how to change the polarity of the DC motor is using a H bridge. We call this circuit called as H bridge. Here in this H bridge, a power supply is applied, and in this way, like VCC and ground, between these four switches. These switches can be a MOSFET or a transistors. So by turning on and off that switches, we can change the polarity of this uh, supply applied to this DC motor. Here you can see, if I apply, if this one is shorted and this one is shorted, what will happen is this positive supply will be applied to this end of the DC motor, and other end is applied connected to the ground, so that the circuit closes in this direction, and makes the motor to rotate in the clockwise direction. So if I apply 1 over here and 1 over here and 0 over here and 0 over here, it will make the DC motor to rotate in the clockwise direction. if I alternatively give 0 sorry 1 over here, 0 over here, 1 over here, 0 over here, what will happen is this switch will turn on or it will get shorted, and this switch will get turned on and it will get shorted, and so the supply will or the circuit closes in this direction. That means the DC motor will get a positive supply here, it will get connected to the positive here, and the other end will get connected to the ground over here. So the direction of the DC motor will also change, and it will run in the anti-clockwise direction. So this way, using a H bridge, we can easily change the direction of the DC motor. Next to that is how to construct H bridge. We are not going to construct this switches and all. They have already made a ready-made IC, which is called which has a number as L293D. This L293D acts as a driver circuit which isolates the microcontroller and the DC motor, and also gives the enough current and voltage to the DC motor when and dif- and and protects the microcontroller from loading effect. And here it has two set of inputs. One is input 1 and input 2 is the first set, and input 4 and input 3 and input 4 is the second set, and correspondingly we have output 1, output 2, and output 3 and output 4. So for controlling one DC motor we need one pair, like input 1 and input 2 is the pair we need along with the output 1 and output 2. So let's take, we are going to interface only one, so I take the first half alone, the left hand side half alone, and to activate this circuit I have to give 1 in this enable signal, so that this part of the circuit will be activated or powered up or enabled. Okay, if I want to enable the right hand side, I have to enable give logic 1 in this pin number 9. Next is I have to give the supply. So this is VCC, and we have to ground. This to ground will be connected to the ground of the breadboard or PCB board along with the heat sinks, so that it doesn't heats up much, because the DC motor will require more current and it will tend to heat this IC fast. So next is from Arduino Uno. I need two outputs. One output will be connected to this input of this IC, and another output will be connected to the input of the next IC, and this output of this IC will be connected to the DC motor. Okay, DC motor we saw. So this way it gets connected to the DC motor, and now how it is going to act as a bridge, H bridge, and along with that how it drives the DC motor. See here we paired this S1 and S4, isn't it? When this S1 and S4 both will turn on at the same time. So if the input 1 is connected to this input 1, and input 1 here, and input 2 over here. So this is the way it is connected. So here we need 4 control, but as they have made a pair, so only 2 controls were required. So those 2 controls are given here, input 1 and input 2. Input 1 will control S1 and S4, and input 2 will control S3 and S2, so that this output 1 and output 2 were connected here. This is output 1, this is output 1 of that IC, and this is output 2 of the IC. So in that way so we get, so this is the basic circuit diagram for the connection, and here is how we are going to interface it in the Tinkercad. We have Arduino Uno, and here we have DC motor and L293D IC is there, and first we have interfaced this, we have connected this 13th pin to the enable pin of this left hand side block. Okay, and before that let us connect all the power supplies. Here we have the power supplies connected, ground and VCC were connected, and enable pin is connected. And the next is we have to take this 11 and 13 from, sorry, 9 and 11 from the Arduino Uno and connect it to the L293D H-bridge driver circuit for DC motor. So input 1 is connected and input 2 is connected, and next thing is the output 1 is taken and connected to the positive of the DC motor, and output 2 is taken and connected to the other end of the other terminal of the DC motor. So this way the connections were done, and one more connection part is made over here is we are using a switch to control the direction of the rotation. So if I give 1 0, if I give positive and negative, it will run in the clockwise. If I give negative and positive, it will run in the anti-clockwise. So in order to switch the direction, we are using a switch over here, and that will be used as an input. So pin number 7 is an input, pin number 9, 11, 13 are the output, and 13 is the enable signal. So how we are going to code it? See, this is the setup part. In setup part, I'm making this pin number 13, 11, 9, 7, all these things as a all this 13, 11, 9 as the output pin, and 7 as the input pin, which comes from the switch. And the next is digital write. This here why I'm set up over here to enable this hatch bridge left hand side of this driver circuit M293D. I'm enabling this part, and next so that's all about the setup part. And next is um, loop. In loop, what we are doing, just like controlling LED, making on and off. So if I give 1 and 0 here, 1 and 0, then it will make the DC motor rotate in the clockwise direction. If I give 0 and 1, it will make the DC motor to run in the anti-clockwise direction. So that I'm going to make the decision based on the switched status. So if digital read number 7, if the switch is connected to VCC, then it will be logic 1. So if it is equal to 1, it will write a high in pin number 11. So here it will be 1 and this will be low, so that it will run in the clockwise direction. If the switch is connected to plus VCC, it will run in the clockwise direction. If it else, it is going to run in the anti-clockwise direction. So that's all about the circuit diagram and the code. So let's try simulating this. So you can see it is connected to ground, and it is rotating in the anti-clockwise direction. How I'm saying anti-clockwise direction, it is the shaft is rotating in anti-clockwise direction, and the RPM is given in the minus sign. And let's try changing the switch. So it should make the change in direction, and you can see observe that, and the value also get changed. And you also, and I think that's all for now. You can try this program, and if you have any doubt, you can join at the discussion time, and you can present your outputs. Thank you all.